So now we're going to talk about the law of sines, and the law of sines allows us to solve triangles that are not right if we have side, 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 or side, angle, side. Okay, and there are two ways we can use the law of cosines. The original law of cosines is your standard form, and we use that when we are trying to find a side length. Okay, but then we have an alternative form, which makes it a lot easier when we are trying to find an angle measure. Okay, you could use the standard form to find the angle measure, but then you have to do a lot of inverse operations, and that can get a little hairy. So if you're finding an angle measure, you may as well just use the alternative form of the law of cosines. Okay, so let's take a look at example number 1. We want to find the three angles of a triangle, and we're given the side lengths 9, 12, and 14. Okay, so I'm going to draw a triangle, and it's not a great drawing, but that's okay. And so here is side A, so across from that is angle A. And side B we'll put here, and so across from that is angle B, and so that makes this bottom one C. All right, and so we have all the side lengths, and now we're trying to find the angle measures, and so we want to use the alternative form. So I'll just start with angle A, and so we're going to find cosine of angle A is equal to B squared, so that's 12 squared, plus C squared, so that's 14 squared, minus A squared, which is 9 squared, and all over 2 times B, which is 12, times C, which is 14. Okay, so notice that in this formula, the side length that's being subtracted corresponds to the angle that you're trying to find. So really all three of these formulas are the same. You're just rearranging the letters. All right, and so then we're going to calculate this value of the fraction, and when we do that, we get about 0.77083 with a repeating bar. I would leave it all in the calculator, and then you're just going to do inverse cosine. And so you're going to hit second button and then cosine of the answer. And so when you do that, though, please make sure that your calculator is set in degree mode, because if it's not, you'll get the wrong answer. You'll get an answer in radians. And so then we have found angle A. So now there are several ways we can find angles B and C at this point. You could use law of sines if you want to. You can continue to use cosine, law of cosines. So in order to get more practice, we're just going to use law of cosines. So now I'm going to find angle B. Okay, and so we know that it's A squared, so 9 squared, plus C squared, so 14 squared, minus B squared, so that's 12 squared, all over 2 times A, which was 9, times C, which was 14. And again, you're just going to plug that into the calculator to get that decimal, and it ends up being about 0.527 with a repeating bar. Again, I'm just going to hit second cosine and then answer in my calculator, so that way I'm not rounding anything. And when I do that, I end up with 58.1, because your calculator should already be in degrees from when we found angle A. Now at this point, you can do the law of cosines on angle C, or since we know that all of the angles of a triangle add up to 180 degrees, and if we feel pretty confident that our angles A and B are correct, then we can just subtract those from 180 to get the measure of angle C. So C is going to equal 82.3 degrees. And so now we have found all of our angle measures using the law of cosines. So now we're going to move on to example number 2. And in this case, we have an angle and 2 sides. So let's just draw this picture. So angle A is 75 degrees, so it's about like that. 75 degrees, and that's angle A. And so we know that we have we have side B, which is 12, and side C, which is 10, and those two are used to create our triangle, or to create that angle A. And so since we have 10 over here on the left, the opposite of that is going to be angle C, and then the top vertex is going to be angle B. Okay, and so we can start off by finding side length A. And here's where we're going to use our standard form of the law of cosines. So we have A squared equals B squared, so that's 12 squared, plus C squared, so 10 squared, minus 2 times B times C times the cosine of angle A, which was 75 degrees. And so you can plug all of this into the calculator, and you might want to be careful on how you plug it in, because remember that your calculator does do order of operations. We never, ever, ever want to combine that. Okay? That is a big no-no. Do not do that. Okay? So in order to prevent ourselves from doing that, I'm going to combine those two, and so I end up with 244. Because 12 squared is 144, 10 squared is 100, so we add those together. And then minus, and then we have 240 times the cosine of 75 degrees. Okay, again, we're not combining that 244 and the 240 because that 240 is being multiplied by the cosine of 75. But you could plug this into the calculator just like that. And we end up with about 181.88. The decimal keeps on going, but that's okay. We're just rounding a little bit. And then we need to take the square root. Now remember, when you take the square root, normally we put plus or minus, but we don't here because we're talking about the side length of a triangle, and so you don't have a negative side length. Okay, so now we have side A. So there's our 13.5. And at this point, we could use the alternate form of law of cosines to find angle B or C. Or we can use law of sines. Since we've already done some work with the alternate form of the law of cosines, let's take a look and see how we could use the law of sines. So let's say we want to find angle B. So the sine of B over side B, which is 12, equals the sine of A, which was 75 degrees, over side A, which we found to be 13.5. Now keep in mind, our answers might vary a little depending on how we rounded side A. All right, and so then we know that sine of B is going to equal 12 times the sine of 75 degrees, all divided by 13.5. And then you can plug that into the calculator. Make sure you do 12 first, and then times sine of 75 degrees, and then you can divide that whole thing by 13.5. And so when you do that, you end up with a decimal of approximately 0.8586. Again, that's going to keep on going. And then we use our inverse function for sine. So we hit second sine and plug in our answer, and we get about 59.2 degrees. Okay, and then just like the previous problem, we know that all the angles of a triangle have to add up to 180, so we can just take that 75 degrees and the 59.2 degrees and subtract those from 180. And so when we add those two together, we get 134.2, and so then when we subtract that, we get that C is about 45.8 degrees. Again, we had rounded some things, so that will be a rounded answer. All right, and that's how we can use the law of cosines to solve triangles. Let's take a look at how we can use Heron's area formula, and this is based on the law of cosines. All right, so whenever we're going to try to find an area of a triangle, and we're only given the side lengths, we have this formula where the area is equal to the square root of the product of the semi-perimeter, which is the sum of all the side lengths divided by 2, times the semi-perimeter minus each of those legs. Okay, so if we want to draw this triangle. So here's my triangle, and here's A, which is 11 feet, and here's B, which is 16 feet, and here's C, which is 24 feet. And I want to find my semi-perimeter, so I'm just going to add 11 plus 16 plus 24 and divide all of that by 2. When I do that, I get 51 divided by 2, which is 25.5. Then I can use that to put it into my formula. And there we go. All right, so we've got the area equals the square root of 25.5 times 25.5 minus 11 times 25.5 minus 16 times 25.5 minus 24. Now you can plug all of this into the calculator. It can get a little messy, so if you're not comfortable with doing that, you could do each of these differences by themselves. So I have 25.5, and so I'm going to multiply that by 14.5 because that's the difference of 25.5 and 11, and then I have 9.5, and then I have 1.5, and so that might just make it a little bit easier to plug into the calculator. And so then when I do that, I get that the area is about 72.59 square feet.